This is AP Calculus AB, year 2010, for response question number 3. For this problem, there are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph above shows the rate R of t at which people arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. For part A, here's our graph by the way. For part A, it's asking how many people arrive at the ride between t equals 0 and t equals 3. Show the computations that lead to your answer. So here, it's asking from 0 to 3, so we're gonna cut that up. So it's asking for the amount of people, so obviously we know that it's area, we're gonna have to integrate somehow. So part A, integrate from 0 to 3, R of t, because that's a function. So for this, we could use trapezoidal sum, which our formula is 1/2 height times b1 plus b2. So here we can separate our graph into two trapezoids. Here's our first trapezoid, here's our second one. So the formula, as I stated earlier, 1/2. Our height is going to be the distance between 0 and 2, which is 2, obviously. Now our base is going to be the numbers at those points. So 0, it's 1,000, so it's going to be 1,000 plus 1,200. Then our second trapezoid, our height is going to be 1. Don't forget the 1/2, of course, according to the formula. And our bases are going to be 1,200 and 800. So just simply computate 1,000 plus 1,200 plus 2,200 plus 1,200 divided by 2 is 600. 600 plus 800 is 1,400. So the amount of people is 3,600 people that will arrive at the ride between t equals 0 and t equals 3. Because for part B, it asks, is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? Justify your answer. So here we have our interval from between 2 and 3. So 2 at our value of y at 2 is 1,200 and our value of y at 3 is 800. That is the people per hour. So there's 1,200 people after 2 hours, and after 3 hours it is 800. So based on that knowledge, we know that the number of people waiting in line will be increasing. Just solely based on the graph. Now we also know that people move onto the ride at a rate of 800 people per hour. So because people are moving at a rate people are moving at a rate of 800 people per hour, And we know that R of t is greater than 800 on our interval 2 at 3. We know that it's greater than 800, so that means that the people are going to be increasing in line. Now, if we were to ask, for example, from 3 to 8, we know that it would be decreasing, but since it's asking only from 2 to 3, we know that it is greater than 800, so that is why the people will be increasing on the line. Okay, for part C, it asks at what time t is the line for the ride the longest, how many people are in the line at that time, justify your answer. So this has to do with maximum, so we need to figure out, we are going to be working with the rate at which people arrive at the ride and the rate at which people get on. So we're going to be working with R of t. This has to do with a maximum, so we need to figure out for which value does R of t minus 800 equals 0. So we have to solve for our critical value, just simply add 800. So here R of t equals 800, we can clearly look at the graph that R of t equals 800 when R of t equals 3. So R of t equals 3. So we know that the ride is the longest at t equals 3 because it's a maximum. Here we could see that from the interval 0 to 3, it is above 800. That's plus, it's positive slope. And from 3 to 8, let me erase this 3 because it's getting confusing. From 3 to 8, it is negative, so that's clearly a maximum. So here, R of t, for our justification, R of t is greater than 800 on 0 to 3, like I mentioned earlier. And R of t smaller than 800 on interval from 3 to 8. So that is clearly a maximum. So therefore the longest line, the line that the longest is at is at t equals 3. Now we're not done with that question yet. It also asks us for how many people are in line at that time. So in order to do that, we need to figure out the total amount of people. So we know that there's 700 people in line already. It's going to be 700. And then we're going to also need to add the amount of people that arrive from 0 to 3, which is what we figured out for part A, which we know is 3,200. Now we're also going to need to subtract the amount of people that got off the ride that exited, or the amount of people that move on to the ride, which is after 3 hours. So it's going to be the 800, because that's the amount of people that get onto the ride, times 3, because it's 3 hours. So from there, just simply simplify. 800 times 3 is 2,400. So it is going to be 1,500 people. So 1,500 people are at the line at t equals 3. Now for part D, it says write but do not solve an equation involving an integral expression of r whose solution gives the earliest time t at which there is no longer a line for the ride. So in order to do that, we need to accommodate for the people that are already in the ride. So it's going to be 700. And we also have to add that to the amount of people that are going to be in that line. So we could just use a dummy variable. And we also have to subtract the amount of people that are getting on the ride in order to figure out when there is no longer a line for that ride. And this would have to equal to 0 because there would be 0 people on the line for the ride. So